Okay, last problem, and this one's kind of a monster. Now, it's kind of hard to think through what you need to do, but every piece that you need in this problem is something that you have used in the review so far. So we start with 2 points, P and Q. And we want to find all the numbers so that PQ has a length of 5. Now, when we're talking about vectors, length and magnitude are the same. Same idea. So what we need is a magnitude of 5. And magnitude is square root of our squares. I'm going to use A and B right now, because I don't want to use X and Y since we have an X there. So, we need to get here, we need to get our vector into component form from our points. So, the first thing, we kind of have a plan. We can set, once we have our vector in component form, we can use this equation, 5 equals square root of A squared plus B squared. But we need to get there first. So, we need to take our points and find the vector associated with them. So when we're dealing with when we start with points, we get to our vector like this. X2 minus X1, Y2 minus Y1. So let's put those numbers in there. So our X2 is actually X. Our X1 is negative 3. Our Y2 is 4. And our Y1 is 1. So our vector is X plus 3, 3. And now we have our A and our B that we can plug into our equation. So here's A, X plus 3 is A, and 3 is B. So I'm going to use this equation, 5 equals square root of A squared, but instead of A, I'm going to put in X plus 3. And instead of B, I'm going to put in 3. So a problem like this is missed very frequently on the exam and on the unit test because of these two pieces. One, you have to be okay with having the X in the magnitude equation. And 2, you have to be okay with getting from a point to the vector, which is really easy when we do it at first, and then I think kind of gets lost in all the little baby equations that come with vectors. Okay, so I know that we have trouble squaring binomials sometimes. Hopefully the binomial theorem kind of trained us out of that. But even if it didn't, make sure that you're doing this for yourself. It's really tempting to lose that middle term. Don't let it happen to you. It's really tempting to lose that middle term when you're squaring a binomial. Now, it is legal for us in this context to square both sides. Whatever we do to one side of the equation, as long as we do it to the other, it's cool. And here, to get rid of that radical, that's what we have to do. So 5 squared is 25, and that cancels our radical. And now we have to algebra ourselves out of this problem. Now, a couple things to be careful of. 1, we have to be set equal to 0 so that we can factor or use the quadratic formula. And using the quadratic formula is a fine thing to have to do in a problem like this. So even if you wouldn't need to use a quadratic formula in this context, if you get a situation that is not factorable or that you're having a hard time factoring, the quadratic formula should always be your next place to go. Okay, I'm done talking, now I'm going to algebra. X squared plus 6x plus 9. Make sure you FOIL that or use the binomial theorem, however you make that happen for yourself. Before I bring my 25 over, I'm going to combine all my like terms. Now I'm going to set equal to 0. And minus 7. This case is factorable pretty nicely. X plus 7, x minus 2. We can plug back in to our original vector. So the vector that we found was the vector x plus 3, 3. The horizontal component was x plus 3, and the vertical component was 3. So what we're saying here is we have two options of vectors that could have a magnitude of 5. We could have the vector negative 7 plus 3, 3. And so that would be negative 4, 3. And that vector, if we were going to find the magnitude, that would, you could, do square root of the squares, or you could say, oh, hey, that would be a 3, 4, 5 right triangle. And we have another option, a vector of 1 plus 3. And so there's your positive 4, 3. Both of those would have a magnitude of. That's a nice problem. You did yourself a favor if you watch this video, because you're going to see something very similar to that. Enjoy.